I'm CJ. I work in Google New York City. I'm a software engineer on Abseil. And right there, it says EIT. That's my little team's tagline. It's everything is terrible. And hopefully I can share a little bit about why that is. So, background information. Here we have an, super pared down example implementation of optional found in the std namespace, also found in the Abseil namespace in 11. So basically, it's a backport of the std version, but implemented in 11 for users that are not able to upgrade yet, like a lot of things in the Abseil library. I'd like to talk about these particular parts of or actually one particular part of the API here, and also the underlying implementation that we used in Abseil up to this point. So, the fun part. Let's zoom in on the operator arrow. Does anyone notice anything about that implementation? Yeah? Yeah? How about that? Scary yet? All right. So, this is invalid. This is incorrect in the case where T is overloaded, or T's operator ref is overloaded. So, what do? Yes, std address of. Except that I didn't tell you, this has a Constexpr overload, and std address of is not defined that way in 11. So this won't compile. Well, what I haven't talked about yet is the underlying data structure is T is a value, and we are unioning it with a dummy value. It's just a tag type. And the reason being we need to directly construct T because there's like an emplacement-based constructor. So we can't just have like an aligned storage, for example. Okay, so can we cast our way out of this problem since we have that dummy? Well, obviously reinterpret cast works. It's pretty common, right? Not in Constexpr. Sorry, no good. Well, okay, well, what does work in Constexpr is static cast, obviously, right? So this does at least get us closer. So we're taking the address of dummy and we're casting to void, and that does work, but casting from void is broken. Sorry, no dice. All right. Now, can we sidestep the issue? This is hands down one of my most favorite aha moments, because I almost solved this problem, almost. So what if we was actually in a length one array of the templated type that we stored, and then we simply decay that to a pointer? This does work. This does actually satisfy our requirements. Unfortunately, that does not satisfy the requirement of the other constructor I talked about earlier, where we need to directly construct into the T, as an emplacement an emplacement type of constructor. And so we cannot do that because arrays require default construction. So that's not valid either, unfortunately, although I kind of wanted to push this anyway, because it's just so beautiful. All right, so what did we settle on? Sadly to say, we did end up going back to the address of and dropping support for Constexpr temporarily while we're in 11. Sorry about that, but these are the trade-offs engineers make. Everything is terrible. Thank you for listening.